So is f continuous on the closed interval -4, 4? Well, we know that this over here is a polynomial, which basically just means that yes, f is continuous. Whenever you have a polynomial function, f will be continuous on a closed interval. So if we're asked the question, is f, or if f is differentiable on the open interval -4, 4, find the derivative of f of x. And since we do know that f is differentiable, we're going to use the power rule, and this is because it's continuous on the closed interval here. So we're going to use the power rule for this equation as our derivative. So when you're using the power rule, you will get 3x squared minus 8x minus 16, and of course you delete this off. And so your answer is simply that. And then when it wants us to find f of -4 and f of 4, you're just going to plug in the values of -4 and f of 4 back into this equation over here. Okay, so when you plug those values in, you will see it written like this. We'll just do -4 because it takes a while. Just -4. And you should get -59. And if you do this for +4, you should also get -59. So the values in this case match once you plug them into the equation. And so when it asks to determine whether or not Rolle's theorem can be applied to f on the closed interval -4, 4, the answer would be yes, because not only do these two values match, which basically just mean that it's continuous, it's also differentiable, the function, which we figured out beforehand. So yes. And then since we know Rolle's theorem can be applied, if we want to find all the values of c on the specific interval, such as the derivative of f of c is equals to 0, we're going to use the quadratic equation, which the quadratic equation is just c equals -b plus minus the square root of b squared minus 2 times a times c over 2a. So we're going to plug in both of these values into this equation. And when you do so, you should get two values. For one of them, for C1, where we use the plus symbol, you should get 4. And for C2, where we use the negative symbol, or the minus symbol, you should get -4/3. But we're not done yet. We can't just say that these are the values. We actually have to verify whether or not these values fall within the interval of -4, 4. So you have to go and look over here, and what you'll notice is that only -4/3 falls into the open interval. And you'll see this if you graph it, but you can also tell just because because 4 is equals to the y here, and it wouldn't fall like within, but the slope here, -4/3 does. So